For two-body problems, we determine the net force. We use vector algebra, and we add the masses, and the net force is equal to the net mass multiplied by the acceleration of the system. So still we apply in Newton's second law of motion. A baseball is struck by a bat while the ball is in the air. What objects exert forces on the ball? Please help me with an answer. So this is a projectile problem. After the ball leaves the bat, it is just like a projectile. What are the forces that act on a projectile? You have a gravitational of Earth that always constant acceleration downward. This is one thing. And you have the resistance of air, right? So this would be the right answer, Earth and air. Consider the three situations below, labeled A, B, and C. Ignore friction. After each system is released from rest, do the tensions in the strings compare? So here, this is fixed. So you have a tension of 2 kilograms, 2 multiplied by G, which is 9.8 or 10 approximately. So this is like 20 newtons. For this one, you have 20 Newton here minus 10 Newton there. It would be in it downward 10 Newton. For this one, 2 minus 2, 20 Newton minus 20 Newton is 0, right? So it would be BCA. Two blocks are arranged as shown and kept at rest by holding the 1 kilogram block. So this is held in place. The tension in the string is closest to. If this is held in place, then as if this rope is fixed to the wall. So what would be the tension in such a situation? You need mass by gravitational acceleration, right? 1.2 multiplied by 9.8. You can round that to 10. So this would be the answer, 12 Newton. A mass of 5 kilograms sits at rest on an incline making an angle 30 degrees to the horizontal. If US is 0.7, what is the friction force on the block? It says the mass sits at rest. So there is no motion involved. There is no motion involved. What is the friction force on the block? In order to calculate friction force, you need the normal force, okay, and you need the angle. So you have mg going downward. Mg 5 multiplied by 10 is 50 newtons. You can decompose this into two components. this will be mg cosine theta, and along the incline would be mg sine theta. Sine 30 is 1/2. mg multiplied by 1/2 would be 50 multiplied by 1/2, which is 25. Okay, so the force of static friction would be up the incline and would be 25 newtons. Two blocks having the same mass but different sizes slide with the same constant speed on a smooth surface. Then move onto a surface having a friction coefficient uk, which stops in the shorter time. Because they have the same mass, they will have the same normal force. Therefore, both stop in the same time. We are done with this chapter. What we learned in this chapter, we learned about forces, the 4 types of forces: nuclear, electromagnetic force, weak force, and the gravitational force. We learned that forces may be contact or field forces. We learned Fick's law, which says that is an object at rest will continue to be at rest or in motion with constant speed will continue to be in that situation, compelled to change that by an external force. And the Newton's second law, which says the net force acting on an object is equal to the mass multiplied by the acceleration. Acceleration will always be in the direction of the force, but the velocity may have a different direction. Any question, Ryan?
Oh, my mic turned on.
Okay. We learned about the Newton's second law. We learned about the Newton's law of gravitation. All objects will attract each other. The force of gravitation is m1 m2 over r squared multiplied by the universal gravitational constant. We learned about Newton's third law. For each action, there is a reaction force equal in magnitude and opposite in direction. We learned about friction, how to calculate the friction. We will need the normal force to do that. The normal force multiplied by the coefficient of friction will allow us to calculate friction. The normal force depends on the applied force and its direction. It can be less than mg or greater than mg. It also depends on acceleration if there is motion. Finally, we learned about the tension force, and we learned that strings and ropes serve to transmit the force between the different systems, the different parts. The tension force can be calculated whether we have static equilibrium or whether we have a moving system. If we have a moving system from Newton's second law, we can calculate the tension. And if it is at rest from static equilibrium, you decompose the tension forces and make the y forces 0, the x forces 0, and you have static equilibrium. And from there, you solve for the unknown tension. When you apply Newton's law, if the system is in equilibrium, then make sigma fx 0, sigma fy 0, and sigma fz 0. If there is motion, make sigma fx equals max and sigma fy equals may. If you have several objects connected together, then you will need to calculate the net external force and to use it in Newton's second law, substituting the total mass for the objects in the system.